Let's look at some key points to note for any type of rational number. First is every integer is a rational number, but every rational number is not an integer. What it does mean that any integer p can be represented as p by 1, and therefore it can be represented as a rational number. However, a rational number, say 3 by 2, cannot be represented as an integer. Therefore, the converse is not true. The second point is every fraction is a rational number, but every rational number is not a fraction. So the fraction can be anything, say 3 by 2, it is a rational number. But if a rational number, say 5, is not a fraction, but it can be explicitly written as a fraction, then it becomes a rational number. The third one is that the value of a rational number does not change when both numerator and denominator are multiplied by the same integer. So let's take a very quick example of 4 by 5 and multiply it by 3 in both numerator and denominator. We get 12 by 15, which can then again be reduced to 4 by 5. The fourth point to note is that the rational number is positive if both numerator and denominator are positive, or negative, and negative if either numerator or denominator is negative. So let's take a very quick example. Say positive 3 upon positive 5 is equal to negative 3 by negative 5, which is equal to the absolute value 3 by 5, whereas negative 3 by 5 is equal to 3 by negative 5 with the final value of negative 3 by 5. Finally, the fifth point to note is that all terminating decimals are rational numbers. And that means that if a decimal, say, for example, zero point 0.8, can be written in terms of a fraction, here it is 4 by 5, it is considered as a rational number. However, a value, say pi, which is 22 by 7, it is not terminating, and therefore it is not considered as a rational number. And that's how we do it.